In this section, we are going to have a look at how you can handle bigger files, some sensitive data, user identity, and how you can sign documents like a contract. Now this section will be a tiny bit more theoretical, because a lot of it will depend on your chosen backend technologies. And since this is not a course on PHP, .NET, or Java, but rather a course on Ethereum and Solidity, I will try to focus mainly on the Solidity part, so that everyone can enjoy the course equally. Let's have a look at user identity and sensitive data on the blockchain. What can we verify for a user identity? Well, we can verify email, we can verify your phone number, we can verify your address. Those are things that are pretty easy to verify on a blockchain. How? Well, we can do a confirmation code, and the user can then link that confirmation code to their Ethereum account. And by doing so, it is also linked to his private key. Now, you have to be sure that you don't generate the confirmation code yourself, because that would mean that you can, as an administrator, register users in your decentralized application that are not really those users. And of course, you don't want that. You want each user to be a real verified person and not something that an administrator could fabricate, because that would remove the trustless part of the blockchain. Luckily for this, you can use Twilio and some other external providers. Twilio is mostly for SMS verification, so that takes care of the phone verification part. Now for sensitive data, there is some stuff you do need to consider, like the blockchain is usually public facing. Of course, yes, there are private blockchains, and while that is a solution, and we will go into that a bit later, but let's assume for now that every blockchain is public, you're on the main Ethereum blockchain. You can store your email address, you can store a phone number, address, or a name on the blockchain, because that is, of course, a huge privacy concern. Now, however, we must prove that we can't tamper with the data, so we also can't purely keep it on our centralized server in our own database. Now, a solution to this is hashing and using your backend storage, your MySQL or your Oracle. And what you will do is you will hash user information and store that in your smart contract. So in short, you can link some anonymous blockchain identity to a real-life identity. Now, some considerations for this is that you should encourage your users to create a new Ethereum account for your application, so that when they use that same account outside of your application, they remain totally anonymous. Another solution, as I said before, are private blockchains. But this does introduce some new problems, like data tampering and data censoring. Luckily, these problems are only really a problem if and only if your private blockchain is purely hosted by entities under your control. So what you want to do is, like, the banks are now experimenting with this, like Bank A will team up with Bank B, and they will team up with Bank C, and they will set up one private blockchain amongst the banks. And even though they are competition to each other, they do already share data right now without blockchain. This way you can ensure that Bank A doesn't tamper with the data, because Bank B and Bank C would say, well, that's not right. You're messing with the data. And it would be impossible, even, because once Bank B and Bank C enter the computation, the network becomes more secure. So let's sketch out like an example flow here. To verify an identity, what you could do is a user enters your application. The user generates a new address, a new private key with MetaMask or Geth or any other provider. Now your backend system could notify the smart contract of a new unverified user. Your third party could send out a verification code, such as Twilio, for SMS verification. Now, as an admin, you can't even see the verification code that Twilio has sent out. Only the receiver will be able to see it. So that way you can't, even when you are the admin, you can't cheat. So that becomes impossible. And then when the user has gotten his code through email or SMS text messages, the user can then verify his identity by entering the code and passing this code to the smart contract. Okay, so that's it for now. Okay, so just to show you guys an example of how you could work with sensitive data, you could just take a JSON like this with your sensitive data in it, such as name, family name, address, and then you can hash it. And you can pass that hash to the function. And of course, your sensitive data would remain inside your own database. And if you, as an evil administrator, would choose to tamper with that data, your hash would not be right anymore. So that's pretty much as simple as it gets. Once the hash is passed to the add_user function, the add_user function will push the user hash on top of the user hash's array of bytes.